everybody, it's Miss Phoebus, and this is lesson 32, factoring special polynomials. So we looked at factoring polynomials with a leading coefficient of 1. We factored polynomials with a leading coefficient that was not 1. Now we have our special polynomials. Remember that we have two types. We have ones that can be written like this. Remember, it's hiding two parentheses that match exactly. And then we also have our polynomials that are written like this, where they match almost exactly, but not quite. So those are our special polynomials that we're working with today. And how do you factor those? We've actually done a couple examples of the ones on the left in our slide and divide and in our regular factoring. So these are more shortcuts than anything else. If you do not recognize it's a special polynomial, then you should be able to figure out how to factor it anyway. And so we're going to look at those special polynomials and kind of a little bit of the shortcuts behind them. Remember that there is an open Google Meet today. So if you're having trouble factoring or doing slide and divide or anything, maybe you need to go over naming polynomials, stuff like that, you can come to the open Google Meet and drop in. I will be here if I'm not doing anything else. If I'm not helping anybody, I'm grading papers on Canvas. So come join me, ask questions if you like. It is not required though. All right, we're still factoring, and we're looking when A is 1 and A is not 1, but these are special. So remember that we're doing special polynomial factoring. And we are on page 134 in the notes, page 134. All right, so we're going to start with our perfect square trinomials. Those are our parentheses squared. And so we're looking at a degree of 2. It's a quadratic. There are 3 terms. It's a trinomial. And A and C are perfect squares. So if you are doing these types of problems, then you are going to be kind of on the lookout for perfect squares. So let's talk really quickly about some perfect squares. 1's a perfect square, 4's a perfect square, 9's a perfect square, 16, 25, 36, 49, let's see, 64, sorry, my brain froze there for a second, 81, 100, 121, 144, 169. You got other ones like 400, 900, my personal favorite, 625, that's 25 squared. So there are lots of perfect squares, but also x squared is a perfect square, y squared is a perfect square. Even x to the 4th, that's x squared times x squared. Those are perfect squares as well. So we're going to be watching out for perfect squares, be it variables or numbers. And we have this interesting setup where here's our x squared, here's our x, and here's our c value. And what we're going to be doing is we're looking at a, and if it's a perfect square, we're going to be taking a square root of that. And C, we're taking perfect square, so we're going to take a square root of that. And then we're going to be dealing with those square roots underneath the squared. We're going to be working with that a little bit. So it looks a little complicated. It'll be okay. So here are your steps to factoring success. This is only for your perfect square trinomials. So we're factoring out a greatest common factor if possible. So watch out for that it should be the first step, just like in our slide and divide problems. Leading coefficient should always be positive. We're going to find the square root of the first number in front of the x squared, the a, and the last number, the constant at the end. We're going to decide on the signs by looking at the middle term. And then we're going to build that factored polynomial, and then we'll multiply to check. And for this one, you need to write as 1 parenthesis squared. And remember that this is a shortcut, but it doesn't always work for every single quadratic trinomial, it's just the ones that are the perfect square. So we're looking for that, can I take the square root of this and get a nice number? So these are special. All right, now we're going to look at number 1. So we've got 25y squared plus 20y plus 4. Now we actually factored this one in the last lesson. It was one of those problems. But I want to show you the shortcut. So this is where you have to think, can I do something special? So 25 is a perfect square. Y squared is a perfect square. And 4 is a perfect square. Now the middle piece, I don't care about. I mean, I care about it, but like, I'm not worried, is it a perfect square? Because it will probably be one. So what we're going to do is we're going to take the square root of each part in the front. So we're going to deal with 2 parentheses, right? Square root of 25 is 5. So each parenthesis gets a 5. Each piece gets that part of the perfect square. And then y squared is y times. All right, in the back, we're going to take the square root of 4. And so we know that the square root of 4 is 2. So we're going to put a 2 here and a 2 here. Now, our decision on what sign's going to be here is going to be based off of that middle term. So you see the middle term is a positive 20y. So because it's a positive, we're going to put a plus here and a plus here. If it was a negative 20y, we would put minuses where those little green pluses are. And then what we're going to do is we're going to multiply and check, but we are going to say final answer is 5y plus 2, all of it squared. Let's multiply to check. So 5y times 5y is 25y squared. 5y times 2 is 10y. 2 times 5 is 10y. Sorry, 2 times 5y is 10y. 2 times 2 is 4. And so we get 25y squared plus 20y plus 4. So it does check out. Let me erase it so you can see the original. It does look like the original. And because it is a shortcut, it's not like I have to do slide and divide. Slide and divide is a little bit different. However, maybe you don't notice that they're perfect squares. Maybe you don't notice, oh, I have 25, that's a perfect square. I have 4, that's a perfect square. Maybe you don't notice that. Slide and divide will still work. So it's a shortcut. That's all it is. Okay, so let's look at number 2. Now on number 2, there is a 1 in front. You can take the square root of 1. The square root of 1 is 1. You can take the square root of n squared. And you can take the square root of 16. So let's look at factoring this. Square root of 1 is 1. The square root of n squared is n. So each parenthesis gets an n. The square root of 16 is 4. Be careful. A lot of people divide by 2. Dividing by 2 isn't taking a square root. All right, do you see how there's a negative on that 8? So because that's a negative, both of these are negatives. And so we can multiply to check. N squared minus 4n minus 4n plus 16. So we get n squared minus 8n plus 16. And so that's what we started with. So we could write this as n minus 4 squared. Now, let's say again, you don't recognize it. You don't notice that it's a perfect square. So could you do, can I find 2 numbers and multiply to give me 16 and add to give me negative 8? Sure you can. Negative 4 and negative 4. So the old method still works. Okay, but this is one where it's like, it's almost like if we weren't doing the whole multiply to check, we would be writing very, very little. All right, so let's look at number 3. Now remember, I haven't been saying anything about greatest common factor. We should be checking for greatest common factor. 4, 4, 1, no greatest common factor. But 4 is a perfect square. I can take the square root of that. I can take the square root of n squared, kind of make that a little diagonal. I can take the square root of 1. So let's do that. Now remember, when you're taking the square root, we're going to put it in each parenthesis. So the square root of 4 is 2. Each parenthesis gets a 2. The square root of m squared is m. Each parenthesis gets an m. And the square root of 1 is 1. Each parenthesis gets a 1. Now, question is, can you tell from the original whether I should have a 2m plus 1 or a 2m minus 1. Because this is a plus, both of these are pluses. All right, let's double check it. So 2m times 2m is 4m squared. 2m times 1 is 2m. Times 2m is 2m. 1 times 1 is 1, so you get 4m squared plus 4m plus 1. So we would write this as 2m plus 1. That makes Miss Phoebus happy. I like seeing that. That's going to help you on a test. Hint, 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 hint. All right, now let's say for a moment you didn't recognize this. You're all like, hey, let's do slide divide. I want to show you that like what we're doing here is a shortcut. So let's just say for a moment we did slide and divide and we said, okay, we're going to slide this 4 to the end and we're going to have m squared plus 4m plus 4. Can we find two numbers that multiply to give us 4 and add to give us 4? Oh yeah, they're 2 and 2. So that means that I'm dealing with, this becomes m plus 2 times m plus 2. And then we're like, okay, we did our slide. Now it's time to divide. What are we dividing by? 4. We're going to reduce those fractions. If you're not reducing your fractions, you want to. Or else you're going to get the wrong number. We don't want to get the wrong number. We're spending all this time doing the right stuff. We want to get the right answer. So bump those 2's up as coefficients. 2m plus 1, 2m plus 1, which gives us 2m plus 1 squared, which is what we got. But that's a lot more writing. It's a lot more work. Because it's special, there is a little bit of a special shortcut. But just something to show you. You want to try number 4? Why don't you pause the video? Try number 4. All right, you're back. Now, I'm not going to do slide and divide, but it does work. We're going to do the square root of the front, the square root of the back. So the square root of 25 is 5. The square root of g squared is g. The square root of 9 is 3. All right, we're going to put minuses in. That's a minus. These guys are minuses. And if we didn't have to check, we could go straight to 5g minus 3 squared. But we're going to multiply to check. So 5g times 5g is 25g squared. 5g times negative 3 is negative 15g. Negative 3 times 5g is negative 15g. Negative 3 times negative 3 is a positive 9. 25g squared minus 30g plus 9. Yay! Look at that! How wonderful is that? Love the shortcut. Personal favorite of mine. But, like I said, doesn't work every single time. All right, here we go. We got another one. I feel like that's just kind of backwards of what we just did, right? The square root of 9 is 3. The square root of w squared is w. The square root of 25 is 5. And then the square, or the negative on the 30 makes that a negative. Look at there. We're done. Now we got to check, but we are officially finished. And when you get really good at this, that's like how much you got to write. We got to check this though. Minus 15w minus 15w plus 25. 9w squared minus 30w plus 25. That's what we started with. We're good. Look at that. I love these. They're so much fun. All right, you want to try number 6? See what you can do. All right, square root of 49 is 7. Square root of b squared is b. I've got a plus in front of my 56, so I'll put a plus there. 16 under a square root is 4. There's my answer, but we're going to check it, so that means we got to write it twice. Don't you be squaring each part and killing puppy dogs. 49b squared. If you don't know what I'm talking about, you might want to go watch the video on multiplying polynomials. I just realized, I was like, what if somebody didn't watch that video and they're like, why is Phoebus talking about killing puppy dogs? So sad, but people do it. All right, so we've got our final answer. I love the shortcutness about that. So much fun. All right. So watch out for number 7. 7's got a greatest common factor. A lot of people just jump straight in and they're like, ooh, square root of 25, ooh, square root of 100. And I'm like, there's a greatest common factor. We want to make sure that this is completely factored, a complete factorization. So we want to do a greatest common factor of 25. So let's pull that out first. So we got f squared plus 4f plus 4. Now, greatest common factor, again, adds to that complete factorization part. I have factored it all the way, but it also takes my numbers and makes them smaller. So, not saying that the square root of 25 is hard, but we have less that we have to worry about. So, we still have our 25 out in front. The square root of f squared is f. There's a plus in front of our 4f, so there's a plus there. And then the square root of 4 is 2. Close it up and square it. Don't forget that squared, because if you just have 25f plus 2, that's a different problem. Let's check it and make sure that we are happy with our answer. I'm going to distribute that 25. 25f plus 50, and then f plus 2. And so we've got 25f squared, that's looking good, plus 50f, plus another 50f, plus 100, 25f squared, plus 100f, plus 100. So no blanks on this one, but I am looking for the check. So I am looking for, can you write it with the squared term as well? So no blanks, do the check, can you write it with the squared term? All right, let's look at number 8. I don't think there's a greatest common factor. 81 is only divisible by 9 and 3, and like 27, and 16 is a bunch of 2s, so I don't think there's a greatest common factor, but 16 is a perfect square. 81 is a perfect square. P squared is a perfect square. Let's figure this out. Square root of 16 is 4. Square root of p squared is p. I'm going to put a minus because there's a minus in front of my 72p. Square root of 81 is 9. Close her up and square it. Let's try it. See how we did. All right, 16p squared minus 36p minus 36p plus 81. 16p squared minus 72p plus 81. And it's amazing how that middle term just kind of comes together, right? I always find it a little bit amazing. All right, let's look at the other special kind of polynomials, our difference of squares, or our plus and minus ones. The degree is 2. It's a quadratic. It's hanging out in space a little bit, but that's okay. There are only 2 terms, though. These guys are going to be binomials. A and C are perfect squares, though, so that part is still around. But there's a difference in what we're looking at. We're not looking at a trinomial. So because it's a binomial, in our brains, we need to start clicking, hey, the parentheses will almost match. Not exactly, almost. One will have a plus, the other will have a minus. But we are looking at A and C being perfect squares, so that's going to help us out. If they aren't perfect squares, look for a greatest common factor. Because that is our first step. Factor out a greatest common factor if possible. The leading coefficient should be positive. If it's not, it'll be helpful if you make it positive. Can't take the square root of a negative number. Calculator freaks out. All right, we're going to find the square root of A and C. We're going to make sure we set this up. One parenthesis has a plus, the other parenthesis has a minus. We're going to multiply to check. And remember that this is a shortcut method. The other methods work too. So we're going to talk about that briefly, just in case your brain doesn't go there. Your brain doesn't go straight to the shortcut. You're like, ooh, I'm going to FOIL this, or backwards of FOIL this. I'm going to do slide and divide. How is that going to work out? What is that going to look like? Okay, so we are going to talk about that. So let's look at 9. We're going to factor. I'm going to go ahead and show you the shortcut. So this again goes back to the square root ideas. So they are similar. But in order to get that 400 to be negative, you have to have that positive and negative in each one. So the 9, the square root of 9 is 3. The square root of n squared is n. The square root of 400 is 20. But to get that to be a negative 400 when I multiply it out, you have to have one with a plus, the other with a minus. Doesn't matter the order. You could have 3n minus 20 and 3n plus 20. But you have to have one with each sign. You can't have the same, because if I had the same, then I would be in what we were working with before, and those were all trinomials. Let's check this. This is going to be 9n squared minus 60n plus 60n minus 400. Notice that my 60n's are going to cancel because one's negative, one's positive, and I end up with 9n squared minus 400, which is what I started with. Okay, so let's say for a moment you didn't think about, I'm going to erase my check there, but you didn't think that this was special. The two terms just by itself should throw red flags that this is different. So just because there's two terms, you should be like, whoa, what's going on? All right, so let's just say for a moment you're going to do slide and divide, because I don't know, that's what comes to mind. So we're going to slide that 9 to the end, we're going to multiply it. You have 9n minus 3,600. Okay, now when you do your multiplication, multiplies give you the last, that works. But when you do your addition, you have to realize that there's no piece that just has an n. There's no middle term. So you can have a 0 there. And then what number times what number gets you a negative 3,600? Well, one's positive and one's negative, that's for sure. And then these are going to be the same number, because again, it's a perfect square. We want these to be opposites, true opposites of each other, because when I add them together, I get 0. So this is going to be a positive 60 and a negative 60. Okay, and then we go into our, this is n plus 60 and minus 60. We did a slide of 9, so we're going to divide by 9. Those are both, the top and the bottom, divisible by 3, so that's n plus 20 thirds and minus 20 thirds. And so that becomes 3n plus 20, 3n minus 20. So if you did not think anything of it other than, oh, I'm going to slide and divide, you're still going to get the same answer. It's just you didn't use the shortcut. So I'm showing you the shortcut method, but what we learn on Monday and Tuesday is going to stay the same. That's not going to change. All right, let's look at number 10. Now, number 10, you should notice there is a greatest common factor. So let's pull that out. We want this to be factored completely. So let's divide by 5. So we get y squared minus 100. All right, now you could do what two numbers multiply to give you negative 100. Those same two numbers have to add to give you 0. You could do that. And that might be where your brain goes. Negative 10 and positive 10, right? That works out. Or your brain may now go into, hey, there's two parentheses, the square root of y squared is y, the square root of 100 is 10. We need one to be a plus, the other to be a minus. So, like I said, I don't have a personal preference what you choose to do. This is a shortcut, doesn't work all the time. But you have to find something that works for you. Just sitting and staring at it, that's not a solution. You have to figure it out. When I get to check this, I'm going to distribute my 5. And by the way, if you tried to do the square root on the 5y squared and the 500, it wouldn't have worked. So if you find yourself in that boat, where you're like, I should be able to take square roots, but I can't, then maybe there's a greatest common factor you need to factor out. My 50y's cancel, and that leaves me with 5y squared minus 500. All right. We have a few more of these. You want to try them? See what you can do? I personally like them. All right, two terms, two parentheses that match almost exactly. One with a plus, the other with a minus. The square root of 25 is 5. The square root of c squared is c. The square root of 64 is 8. I'm done other than my check. 25c squared. Wouldn't it be nice if they were all like that? I wish. But, nah, it's not all the time. 25c squared, these guys cancel, minus 64. Woohoo! We got what we started with. I'm going to try number 12. I'll pause the video, see how it goes. All right, the square root of 4 is 2. The square root of h squared is h. One gets a plus, the other gets a minus. Square root of 49 is 7. Let's check it. 4h squared minus 14h plus 14h minus 49. 4h squared minus 49. That's what we started with. How you feeling? You doing okay? All right. Now, if you look, 15, you go square root of 28. Ah, square root of 7. Ah, yeah, you're not supposed to. Because there's a greatest common factor. Let's find it. What do you think? 28 and 7 are both divisible by 7. So we get 4k squared minus 1. 4, you can take the square root. K, you can take the square, k squared, sorry. You can take the square root of that. And then 1, you can take the square root of that. So let's rewrite this as 7. And then 2 parentheses. And then the square root of 4 is 2. The square root of k squared is k. One's a plus, one's a minus. Square root of 1 is 1. That's our answer. Let's check it. I'm going to distribute here. So I'm going to have 14k plus 7. And I'm going to multiply that by 2k minus 1. Now you could multiply the two parentheses together and then distribute the 7. A lot of times what happens, and this is incorrect, is that people multiply both parentheses by 7. Don't do that. But you want to make sure that you are multiplying just two things together, and then, sorry, I'm talking and trying to do math at the same time. Multiply two parentheses or two things together, and then multiply times the third. Get that up. Plus 14k minus 7. Oh, look, they cancel. That leaves 28k squared minus 7, which is what we started with. All right, now some people are going to freak out with 16, but I already told you at the beginning that x to the 4th is a perfect square. X to the 4th is x squared times x squared. A perfect square is just a number times itself. In this case, our number is a letter. It'll be okay, I promise. Okay, so we're going to take the square root of both parts. Now this is actually an example in our standards. So even though this is quartic, and we've been factoring quadratics, it does pop up. So we're going to take the square root of each part. We know that because this is a binomial with a negative sign in front of our y to the 4th, one's a plus, one's a minus. X to the 4th is just x squared times x squared. Y to the 4th is just y squared times y squared. Let's check it out. X squared times x squared is x to the 4th. X squared times negative y squared is negative x squared y squared. Y squared times x squared is a positive x squared y squared. Remember, I like to put my letters in alphabetical order. A positive y squared times a negative y squared is a negative y to the 4th. These guys cancel, leaving behind x to the 4th minus y to the 4th. Look at that. So x to the 4th, pretty much anything that has an even exponent is a perfect square. So x to the 6th is just x cubed times x cubed. X to the 8th is just x to the 4th times x to the 4th. So you have perfect squares when you have these even exponents. All right. I'm going to try some of these? Why don't you try 13? All right, we got two parentheses because there's only two terms. One's got a plus, the other's got a minus. Ooh, is there a greatest common factor? There is. Let's pull that out first. Greatest common factor of 9. Got 9w squared minus 4. We want that 9. The square root of this 9 right here. The square root of this w, the square root of this 4. So the square root of 9 is 3. The square root of w squared is w. The square root of 4 is 2. And then we multiply to check. 27w plus 18. And that's going to become 27 times 3 is that 81 w squared. 27 times 2 is negative 54 w plus 54 w minus 36. These guys cancel, leaving behind 81 w squared minus 36. All right, this one's got mixed variables. Okay? Doing all right? There you go. We're going to do it no different, except we're just going to add an extra square root. Okay? There is no like terms. There is no greatest common factor. So we're just going to do square root, square root, square root, square root. That's all we're going to do. So we know we have two parentheses, just like we usually do. One's got a plus, the other's got a minus. Square root of 16 is 4. The square root of x squared is x. The square root of 9 is 3. The square root of y squared is y. Guess what? We're done. We're going to check it. 4x times 4x is 16x squared. 4x times negative 3y, negative 12xy. 3y times 4x, positive 12xy. Again, I like my variables in alphabetical order. 3 times negative 3 is negative 9. Y times y is y squared. These guys cancel. And we're left with 16x squared minus 9y squared. And that is what we started with. So don't let the double variables scare you. It's going to be okay. It'll take care of itself. Just make sure you're doing what we've been doing, taking square roots. That's all. All right, let's see what else we got. Okay, so that's the end of this video. There is a polynomial review tomorrow. There is an open Google Meet today. So if you have any questions or want to talk about anything, you need to probably be doing, well, do the open Google Meet. It's completely optional. The polynomial review, I highly, highly, highly recommend it. There are two things that you need to fill out, one before test 4 and one about the end of the 9 weeks and stuff that you need to talk to your parents. Those are worth points. They are assignments. They are due Thursday by 5 p.m. There is no extension. There is no I'm sorry, I didn't do it. There's no please let me not get a 0. You do it. Okay, you've been warned. If you're skipping this part of the video, shame on you, because I already know who you guys are. You haven't been sending me your middle names and your favorite shapes and your favorite bands and all of that stuff. I know who you are. So anyway, make sure you're doing those things. You have a test. You get to choose either Thursday or Friday. You do not have to email me what day you're taking the test. If you don't take the test, it goes in as a 0. But you should, by this point, know that there is a test. You get to choose the day. You get to choose the time. If you start that test and you are not able to finish it, that's not my fault or my problem. You communicate with your parents. Let them know when you're starting. If there are internet issues, that's a different story. Contact me. But none of this not communicating and, oh, it's the end of the 9 weeks, it's already past fall break, and oh, by the way, I didn't take test 4 because the internet was out. No, there is no reason why that should be happening. We should be in communication as soon as that is happening. You are emailing me and I'm getting back in touch with you, but if you are not talking to me, there is no excuse. No communication, no excuse. Okay? We are getting ready to wrap up the 9 weeks. Thursday, tomorrow, the board is meeting to figure out what we're doing after fall break. So you might want to pay attention to that, or get your parent to pay attention to that, or try to figure out after the board meeting what happened. Sometimes they put something in Johnson City Press, or they put it on the news, or you can watch the YouTube live stream. There's lots of options there, but you might want to see what's going on the week following fall break and make any decisions. So if you're like, you know what, I don't want to come back at 100%, I want to just stay virtual, you might want to get on that. And there is a form to fill out. If you are virtual and you're like, you know what, I really don't want to stay virtual, I want to come back, you might want to see what's going on there. So these are things to think about. I am very tired and looking forward to fall break. I hope you guys are too. If you are behind, you're going to be able to get caught up, but if you just don't do the work, I can't give you the credit for it. So, you know, there's people that aren't doing too hot because they haven't been doing the work. And if that's you, you need to get on it. I will help you. But you haven't been saying a whole lot to me, and you might want to fix that. So if you are doing your work, I got people with over 100. Congratulations. Love this. Yay. Doing what I'm asking you to do all the time. I love it too. So just know that, you know, I'm here for you. If you need something, you gotta say something. I will do whatever I can to help you out, but you need to be also doing what I'm asking you to do as well. So I will see you in the next video, which is our polynomial review. So I will see you in that video, and then you'll be taking a test, and then it'll be fall break. Yay! All right. Bye, guys. See you in the next video.